send me by email test on paper and submit the test online. Okay, today is the last day. My intention is tomorrow in the morning, I start grading the test number 3, no? Okay. So for the test number 4, every student needs a calculator. Okay, I recommend this calculator because it's cheaper and strong. Of course, we're using any scientific calculator because we are working with the new functions. No quadratic function, no parabola anymore. We study with the transcendental new functions, exponential logarithmic function, que es impossible computed by hand. Entonces, any graphic calculator, this is the cheaper, and what is expensive, but it's okay. Forget about expensive. Okay, this is super fantastic. A calculator. Okay, we need calculator because we need to compute special functions. The name of this special, no study today, but soon. Maybe today we introduce at least one. Soon. One more important thing. Well, it's okay. We start. Let me know. It's okay. Okay, Jordan. I know that you are okay. Let me show you. This is fantastic. It's a TI 83 Plus. Yes or no?
Yes, sir.
Do you know how we get working with this good, or we need assistance?
A little bit of assistance.
Okay, don't worry. I have another exactly like you, but in another room. Entonces, in the moment, I bring every calculator and I show you in details. But it's important that every lecture, everyone bring calculator, okay? Put in your on this your calculator that you want working in the test number 4. Okay, guys, let me know if you see or no the whiteboard. Do you see the whiteboard? Okay, super, Andreina, thank you. Entonces, this is the topic that we discussed today, or at least the first topic that we discussed today. Entonces, I want to recall one thing that we studied in the test 2, that was, Claudia. Okay, thank you, Claudia. Remember, we have a domain. We have range. And we have different situations. For example, let me try the 3 fundamental situations. Okay, I repeat again: domain, range, domain, range. Let me make it zoom. Domain, range. 3 possibilities. Remember, domain is the set of the x value, no? And the x value is the first element in the function or the relation, no? Suppose we have 3x element, and we can associate with the 3 element in the like that. Look, y1, y2, y3. Okay, remember, domain is the first set. The direction of the relation is like that. This is a typical 1-to-1. 1-to-1. Because one element of the domain is associated with only one element in the range. But we have another possibility. We have another possibility is something like that. Suppose x1 again, x2 again, x3 again, and you associate, for example, 2 elements with this y, and this element with the one another y, and this is stay alone, no associated with nothing. Nothing. This is many to one. Many to one. But remember, this is a function also, because the most important in the definition of the function is one. Here. One. And we have the third situation in which x1, x2, x3, in which one element in the domain is associated with two elements in the range. This is y1, this is y2. And this I don't care with this. This is one to many. Entonces, this is totally violation for the definition for the function many. Entonces, this is no function. The only get function is one to one and many to one. I suppose you remember very well this. Yes or no? Do you remember? Remember, do you? Okay, good. You remember. The answer is yes. Everyone remember, right? Good. Now, what is the one-to-one is like a special, no? Why is it special? Because, for example, I want to find the inverse matrix. Look, this is a new idea. Inverse function. What is the inverse function? Let me make a zoom to see. Inverse function is, guy, if you want, go in the opposite direction. Go in the opposite direction. Well, in the one-to-one, when you go to the opposite direction, we have no problem. The one-to-one is one-to-one. Pero en many-to-one, when you try in opposite direction, entonces no many-to-one anymore, it's one-to-many, and one-to-many is completely violation of the definition of the function, no? In conclusion, this new idea, inverse function, is only possible when the function is one-to-one. Otherwise, no. But the inverse, the first thing that you should do in this problem is prove somehow. I want to explain how. If my function gets given is one-to-one or no. If the function is one-to-one, therefore the inverse exists. Otherwise, no. And don't. It's impossible to do something. Okay? Now, the notation that we are using for the inverse function notation. Notation is the name. It's f raised to the -1. Notation is this. But this -1 is no negative one exponent. No. This is no 1 over f. No. It's just symbolic. F and -1 is symbolic way. You know, mathematics have a lot of symbols que represent inverse. But there are many examples. You know, intuitive idea about inverse function. Okay, for example, one function que es f of x, que suppose que es x plus 10. I don't know, 10. I like 10. The inverse function is x minus 10 because it's the opposite. So how do you know? Intuitive idea. After I want to explain in detail that part. Intuitive idea is you pick one number, suppose 5. 5 plus 10, 15. When you evaluate in the function, 15. Now I go backward in opposite direction. As you put 15 in the inverse function. 15 minus 10 is 5. Wow, we come back at the beginning. It was 5. That is opposite operation. This is making sense. Okay. Addition and subtraction are opposite operation. Likewise, multiplication and division. Suppose another function g, que es the multiplication by 2 to x, and the inverse function of g. You need to be familiar with the notation. No? Inverse function is x over 2, no? X over 2, division by 2. The multiplication by 2 and the inverse is division by 2, no? And there are several examples. Suppose another function, h of x, is equal x squared, the parabola. And the inverse function for the parabola is square root x, right? Suppose que yo evaluate h en 5, I don't know, 1, I don't know how. I use a 5 always in my example. A 5 squared is 25. And when you plug it in here in the inverse function 25, it's a square root 25, okay, 5, and we come back at the beginning. At the beginning was the supposition that x is 5. So it's like you know, the inverse function is not new for you, no, it's on DOS, no, the original function somehow, no, and we come back to the when you are doing the composition, this and this. Remember, composition is one function inside another function, but don't worry, I want to record this in detail. Well, the composition is the identity function, no? Because we come back to the same number. I suppose 5. I don't know, because I like 5, but you suppose 4 is exactly the same. 4 squared is 16, square root 16 is 4. We come back this. This is the intuitive idea. Any question about the intuitive idea? We have a lot of information about inverse function. And we discussing today several examples. Okay, no problem. You get the idea? Okay. So now, the first challenge is, how do you know that my function is one-to-one or not? Well, the fantastic way to prove that one function is one-to-one is using one thing is called a horizontal line test. Horizontal line test. I suppose that you remember vertical line test. Just in case I want to record. I suppose that you remember vertical line test. Vertical line test that we studied in the test number 2 is one test that allows verification if the graph of the one function is function or not. Suppose one couple of the example, suppose one example like that, suppose parabola, and suppose another parabola like that. So this is when you apply the vertical line test, is basically infinity hypothetical vertical line if cross in only one point, pass the test, and here crossing to fail the test. Now you prove with the vertical line test if this graph corresponded with a function or no function. Okay, the vertical line test allows us to determine if the graph. Oh, no, okay. You have, maybe you have, suppose we have function, and you have no idea. You go to Desmos and do the graph of this function, and you apply the vertical line test, and you determine yes, no, fail, pass. But the horizontal is similar. But what is the objective for the horizontal? Determine if the function is one-to-one or not. So determine if the function is one-to-one or not. Okay, it's the idea for the horizontal. Let me see example. Suppose this graph, two graphs. Suppose one graph like that, similar to the cubic function. And another case, parabola, square function. Now you apply one thing is called a horizontal. It's similar to this. You are doing hypothetical, but in this case, horizontal line. See, crossing only one point, yes, pass the test. Is 1-to-1, super. However, the parabola failed the test. The parabola failed the test. Okay. The parabola is not invertible function. No, the answer is no. But I want to explain that maybe yes, under certain restriction. Okay, suppose another. Actually, see, I asked you in the test, the function f of x equal x squared, find the inverse function. The answer is do not exist because this function is no one-to-one function. However, you say, well, professor, you explained right a few minutes ago the square and the square root are inverse function. Yes, that's correct. The reason is I want to do the graph of the entire parabolas, one half of the parabola, like that. I delete that part. But why you delete that part? Because I consider only the positive number. So I introduce restriction. You put semicolon here, and you put x greater than or equal to 0. What the hell is that, professor? It's a restriction. This is a restriction. Do a restriction in the domain. And my problem, the domain for this new function. Okay, by the way, this function have this mathematical expression. However, the domain of this is all real number. I suppose. But the domain of this is no real number. It's bracket 0, infinity. I suppose only under the positive number. Yes, he passed the test because when they apply, they okay, Ashley Jones, okay, welcome. When you apply the horizontal line test, pass the test. In this case, because crossing. Okay, so we can introduce restrictions, not always, but sometimes, in order to, and you can see in pre-calculus, the student need to take pre-calculus. Okay, one, for example, some trigonometric functions, because in pre-calculus study trigonometric functions. In trigonometric functions, sometimes you have function que es no one-to-one. But when you introduce restriction in the domain, become one-to-one. Okay? Okay? Okay, so let's move on. Well, no, not yet. I need to explain one more thing. Okay, a super important idea is, look. Okay, guys, let me stop and let me ask you, everything is clear, understandable, confusing? Confusing? I saw one beautiful face. What is it? Olga, Amaya, Olga. Okay, clear, right? Okay, super. Let me come back again to the whiteboard. Okay, good. Everyone follow me. Okay, good. Clear. Claudia is saying, clear, professor. Good, Claudia. I know that you are good student. Now, one more thing, important. This is very, very easy to understand. However, it's important. Look, before start example, remember the idea for the inverse function. We have domain, we have range. 1, 2, 3, 1, 2, 3, 1-to-1. So I prove somehow that this function is 1-to-1. This is 2, 3. Perfect. Therefore, the inverse function, this is, and this arrow represent inverse direct function. Entonces, en blue color, in opposite direction, this is the inverse. And remember, the symbolic way to indicate inverse is using like a -1 But actually, this -1 is not exponent. It's a symbolic way to indicate case inverse. So the inverse function, yes, exists. Nice, beautiful. But remember, the domain is this set, and the range is this set. So it's a domain of the original function and the range of the original function. Domain of the original function is equal the range of the inverse, because you interchange the set. This is now the domain of f inverse, because this is the first set in this direction, and this is the range of the inverse. So I forgot to write here domain of the original, and this is the range of the original. Entonces the range of the original, look here, is equal the domain of f, and sorry, and the range of f is equal domain of the inverse. Keep in mind this relationship between the set, because now in this arrow diagram it look like straightforward, no? But in the real life, when you are doing the problem and you need to apply algebra, you don't remember very well. And one more thing before the example. When you are doing the composition, do you remember composition? Composition to function f, composition g of x. This is composition. Composition. Or some book called composite. It's the same, composite function, composition. This is like a one function inside another function. And the order is extremely important, because the first function in the game is g. This is the composition, remember, right? Suppose que I am doing the composition between any function and its inverse. Basically, the thing is apply the inverse first, and after apply the original. Suppose I switch the order. This is the inverse and the original. So in this case, the original first and the inverse second, no? And you know very well, wow. The professor explained me that this is no community. So when you compute, for example, G composition F, no, it's different to the G composition F. And there are several contra examples that illustrate this idea. However, magically, in this special situation, que is the function and the inverse function, que is a family, it's the same. It's the same. You get the same result, and the result is x. The x is, guy, the identity function. Okay. I explained at the beginning, if, for example, you have phi and you square phi, suppose que, o sea, basic es the idea, suppose que the original function is a square. Suppose que the inverse function, I suppose, I don't know, I want to prove mathematically this statement, I say that it's a square root. The square root and square is inverse function. And when you pick, for example, no phi anymore, you pick 4, x equals 4, when you evaluate in the original, it's a square, it's 16, no? And when you pick 16 into the inverse function, there's a square root 16 is 4. And we come back to the same value. That is the reason the composition, any function, any, and is inverse, the answer is identity function. We come back at the beginning. Okay? Let me start. See, you have no question. See, everything is clear, confusing. Let me know, guys. This is the moment. Okay? No problema. Everything is okay. Wow. You are the best student in Miami-Dade College, right? Easy, clear. Okay. So you help me now. You help me now. Okay, so you understand, you help me now. Let me start for the example. I bring, I suppose, 3 or 4 examples. I don't know. Suppose example 1. Example 1. Example 1. The example 1 is the function. So one function is given. F of x is equal x cubed plus 3. Entonces, what do you want to investigate in that function? Bueno, step by step, 5 steps. Step number 1 is determine if it is one-to-one function or not. Because this is important, no? Because if the answer of this question is no, we stop. We cannot do anymore. Okay? Because the answer is yes, that function is invertible. And at least I know that the inverse exists. So the second step is find the inverse function expression. Okay? Number 3 is compute the domain and range. Pero domain and range of what? Of both. Of the original and its inverse. Actually, we need to compute 1, 2, 3, 4 set. Domain of F. Domain of inverse and range of inverse. Number 4 is verify using this statement F composition F inverse is equal F inverse composition F, and this is equal identity. So in both directions. And finally, number 5 is do the graph. Do the graph of what? Of the direct or the inverse? Both. And surprise, because you see one symmetry, special symmetry. Special symmetry. Symmetry is why, no? Symmetry here. Okay, special symmetry. So we have 5 steps. You say too long, professor, okay? It's too long. Okay, let's do it. What do you think about the first topic? Is one-to-one, yes or no? Okay, my function is f of x equal x cubed plus 3. Wow, I have no idea. But why the professor explained me one test is horizontal line test. Yes or no? Horizontal line test. It's the only way that we have to prove the one function is. So immediately I put in decimals. Well, no, not necessarily decimal. Well, okay, we are doing decimal, yeah. I know the collection of the library of the function that we study in college algebra, that is y equal f, you know? But this is no the basic, this is the transformation. Pero okay, pero es plus 3. And plus 3 I know is the vertical shift up because of plus 3. So I suppose it's something like that. It's similar, no? Y is equal x cubed plus 3. Okay, not necessarily sophisticated decimals using the intuition, no? After we are doing decimal, of course, for verification, the thing we analyze is correct, no? And you apply right now the horizontal line test. And when you apply in the blue, the horizontal line test, fail or pass? Pass or fail? Come on, fail. Everyone is agree get fail or pass? Pass. Pass. Because the horizontal line gets the green color, cross, and only one point, the blue curve. Yes or no? Look at that. example que do not pass is something like that. Suppose the another example. Suppose another example like that. When you are doing the green curve, fail. Pero this pass, this no. Got it? So another line doesn't count. Yeah. Every line count. Every line count. Every line count. What kind of line? Okay. A ver. Let me see. I need to get you understand very well this. This is my.
I just got confused with the black line.
I know. Okay, I know. This is the axis, X and Y. Okay, my curve, I want to apply the test, look like that. Y equal X cubed plus 3. Now, in green color, I put the hypothetical horizontal line, que is the tools in the test. Okay, and cross in 1 point. No in 2 points. En 2 points, 1 point, pass. Entonces es obvio que pasa. Yes or no? Do you understand, Jordan? Jordan, come on, honestly. You say no, yes? Clear. Super. Okay.
Hello.
I'm here.
Okay, so Professor, let me just make this clear as possible as I can. If it's passing more than one line, it's considered pass?
No. Okay. When the line green color cross the curve and only 1 point pass. When the line in green color crosses the curve, que es blue color, and only 1 point pass the test. Clear now?
Okay, I get it.
Clear now?
Clear.
Eso. Bueno. Ok. Si crossen en 2 or more, no. Okay, entonces the thing that we covered so far is que the function que we studied in the example 1 is 1-to-1 because pass the horizontal line test. Therefore, this function is invertible. In other words, the inverse function exists. So the inverse function exists. Okay? Entonces, my second step, que is the most important step in my opinion, is determine the expression. Okay, look at that. Find the F inverse expression. The expression for the inverse. Okay, what is the procedure? Pay attention. This is the most important moment. I copy. F of x equal x cubed plus 3. I copy one more time the original function is given at the beginning. I replace f of x for y. Because you know very well que f of x and y is the same. Remember, this is called a function notation, and it brings me some advantage to analyze the function, but it's the same stupid thing, right? Now, this is a crucial moment. You interchange x and y. This is super important moment. In order to find the expression, the new expression for the inverse, you copy here x, y cubed plus 3. Boom. And this is the inverse function. Oh, but it's ugly. It's not good, professor, because this is the implicit form. And implicit in algebra is when the y is not isolated. The implicit, Desmond is fantastic, because Desmond don't like you put equation either way. But in the graphic calculator, TI-89 or 83, es antique, you know. Entonces, you need to express it in explicit. So the first thing you should do is write in explicit. Explicit is a technical word it's using to see is more clear, more understandable. Basically, it's solve for y. Solve for y. Isolate y. Well, solve for y is easy. I subtracting 3. And you apply cubic root both sides. Because I want y alone. Entonces, cubic root x minus 3 is equal y. And this y is the new y, que es the inverse function. Conclusion. The inverse function expression is cubic root x minus 3. End the story. Oh, no, end the story. I leave that part. Okay? Finito. I don't. I do that. This is the cubic root. I'm making sense or no? Compare the original function and the new expression que I found, que es the inverse function. Make sense que es inverse function or no? Using your imagination, your intuition. What do you think? Make sense que es inverse or no? No? Make sense or no? Let me know, guys. No? You have no idea. Totally lost. Remember, multiplication, division, addition, subtraction, opposite. Clear? Okay, he said clear. Okay, Jordan is it's clear. Okay. I understand, but I want to prove. Okay. Use intuition first. My function, my original function, according to the order of operation is, Claudia, look, you raise to the cubic power and finally plus 3. This is the order of operation, no? And here is different. It's subtracting 3 and find or try to find cubic root. In order to understand that this is perfect matching, let's do in the verification. No, I want to skip temporary. I want to skip. Suppose that this is 4 and this is 3. Let me verification. Let me verification. Verification. I want to copy. Look at that. I want to copy the original. Okay. I want to copy its inverse function, que I suppose is correct, but I want to verification. How you verification? Well, you are doing, for example, the composition F inverse, in both direction, F inverse, composition F. Y I suppose que the answer is identity function. I suppose. Si es no identity, entonces we are in trouble. Mistake. So in this case, inverse function. Okay, look, let me use another color. Inverse function first. Inverse function is this function. And this function, you substitution here. So in other words, composition, remember, is one function inside another function. You replace what? You replace x cubic root x minus 3 raised to the cubic power plus 3. Do you understand the thing I am doing or no? It's confusing? Okay, you copy the, you copy the entire expression cubic root x minus 3 and replace in this. In other words, we are doing the composition this inside this. Do you understand this or no? This algebra. Do you understand or no? No clear. Come on. I can explain in different way. If you don't understand, I can explain. Yeah, this is my first example, okay? Suppose que it's easy. We have another more complicated. Yes or no? Do you understand? Okay, this is easy question. Yes or no? Yes or no? Clear, not clear? Is the word you prefer?
Clear.
Clear. Entonces now, look at that. We're almost doing. I know very well that cubic power and cubic root cancel out each other. Entonces stay alive, x minus 3 plus 3, no? X minus 3 is expression inside the radical, okay, without radical because they cancel out. Plus 3 positive and 3 negative cancel out. Wow, identity function. Exactly we predict. In the other direction, let me use another color. Suppose que F go completely and inside this. Boom. So we have cubic root, big cubic root, because instead of X you copy a cubic plus 3 minus 3. This minus 3 is this guy. Okay, now 3 positive and 3 negatives cancel. Stay only cubic root of X cubic. Again, it's cancelled and stay identity function. Now, this is the confirmation that my inverse function is okay. This is corresponding perfectly with this. It's the opposite direction. It's the opposite direction. Okay, not bad. Not bad. I like that. However, I want to go to the this. Remember, we have 5 steps in this kind of problem. No, it's too long. Wow. The second one is domain and range. Okay. We come back. Okay. Let me. I can erase the board or no? I suppose I am record, no? Yes, I am record. I can. Okay. I want to erase the board. Erase the board. Erase the board. I want to copy one more time. Do you see the whiteboard or not yet? Whiteboard, do you see or no? Yes. Okay. I copy here the original function que I have at the beginning. And I discover that its inverse is cubic root x minus 3. Okay. Now I want to copy domain of f. Boom, boom. The range of f. Domain of inverse. And range of inverse. Okay, let's focus in the domain of this. Focus in this, please. Everyone, I need help, strong help. What, in your opinion, is the domain of that function? Come on, guys. Come on, extra credit. The student can get the answer to this. Come on. Domain of this. What is the domain of x cubed plus 3? And why? If you don't know, it's because you don't learn very well college algebra. Come on. What is the supposition? When they explain to you several times, domain of the function, what is the supposition? The supposition is 3 and infinity. No. The supposition is for any arbitrary function, the supposition is the domain is all real number, yes or no, except restrictions. It's the bad guy, no? Pero not always we have restrictions. Sometimes we have restrictions. The restriction almost got it. Flora. The restriction is when you have division, the expression in the denominator, no zero. I know. Square root, the expression inside, non-negative. And the combination of this and this, and their combination in general, is P over radical E is E positive. Now we discussing this 40 times, no? Yes or no? We discussing this 40 times. And you apply this idea. It's a Flora, yes. We discussing, so we apply this idea exactly in the function I put inside the box. Okay, by the way, this function is a polynomial function, yes or no? X cubed, degree 3, no? Plus 3. This function is a polynomial function. Entonces, my question is, this function have restriction? Yes or no? This function have, yes. Flora, what restriction? See, we have no denominator. See, we have no denominator. And we have no square root. Ah, the radical. Oh, okay. I am talking about the function inside the box. This function. Sorry. No. Entonces no. Okay. Okay, no restriction. Si no restriction es because the domain is, Jordan, no restriction. Entonces, si es no restriction, Andreina, no. Andreina say no. What is the domain? No, okay, Flora, no, sorry. Don't say sorry. You are a student. You understand very well this problem or mistake. Entonces, what is the domain? What is the domain of the function que I enclose in the box? What is the domain of this guy? See, we have no restriction. Entonces es real number. Very well, Flora. Ahora, be careful. And remember, domain of F is equal the range of the its inverse. Automatically, see, I know this guy, Because remember, the inverse is the same set, but in opposite direction, no? The domain is the initial, range is the final, but in the opposite direction. They are coincidence in between final and initial, no? It's obvious, right? Ahora, be careful, because that function is the inverse involve cubic root, no square root, and the restriction is only for the square root. Okay. Let me explain this in detail. Look at that. You know very well. Look at that. Two graphs. This is the graph of the square root. We have no negative part. There's a reason que the expression inside is no negative. However, cubic root, the function look like that. Similar, but we have positive part and negative part. This is cubic root function. Do you remember this graph or no? You don't remember? Don't worry if you don't remember, no? Okay, so basically, a square root 16 is 4. Okay. A square root negative 16, not real. This is this case. But a square root 27 is 3, and a square root negative 27 is negative 3. Yes or no? That is a reason 1, 2, 3, 1, 2, 3, and positive 3, and negative 3, we have, 27 and negative 27, yes, x value, we have. Therefore, be careful when it's cubic root, sorry, I forgot the 3, the index. In this case, 2 is invisible. We have positive and negative. So again happen que is all real number. A set positive number and negative number. So this is perfect coincidence. In this case, no always. Que this set is the same. 4 set is the same. Do you see or no? Do you understand? Polynomial, restriction, cubic root, no problema. Square root, yes, pero cubic no.
So, sir.
Yes, please.
So as long as there's no restriction, I hope I'm not oversimplifying this, but as long as there's no restriction, then it's always all real numbers.
Exactly.
Okay.
Exactly. Okay. Repetition again the idea. I want to repeat 41 times, no? Listen to me. I ask you, what is the domain? You ask by yourself. I know that the domain is all real number except restriction. I try to find restriction. No restriction, all real number. End of story. See, I discovered using equation inequality que the restriction is 1, 2, 3. Entonces the domain is all real number except 1, 2, 3. That's it. Okay. Let me go now to the most interesting part, que es do the graph. We are doing by hand, but after we are doing by the decimal, of course. The real life, we are using decimal always. But in this case, I want to emphasize by hand. Suppose I want to do the graph of the above function. No, not good. When I have rule, this rule. Whoa. Okay, good. Okay. Let me, no, 1 degree, no, coño. 0 degree. Yes. Okay, horizontal line. 90 degree vertical line. This is my axis, X and Y. Okay, 90 degree. Okay. So I wanted to do the graph, of course, roughly by hand, of the function y equal x cubic plus 3. Yeah, I know my knowledge about the transformation, que is cubic function, plus 3 is up. However, look at that expressed in function notation. If I want to find the y-intercept, you en 0, que 1 es 0 cubic plus 3 es 3. Es 3. The point is 0,3. That's 0,3. 1, 2, 3 is the y-intercept. 0,3. Now, suppose another point I want to evaluate a little bit before and after, maybe 1 and -1. 3 points is enough. And evaluate the function in 1 is 1 cubic plus 3 is 4, no? Because 1 cubic is 1 plus 3. The point is 1,4. Entonces 1,4 is here. Okay, I take advantage of the symmetry. Oh, no. And -1. And -1 is -1 cubic plus 3 is -1 cubic es -1, ¿no? Plus 3 is 2. Okay, entonces 2 is here. At this point is 0,3. This point was 1,4, and this point was -1,2. Okay, using my blue color, I know the shape approximately. My function look like similar to this idea. Because I know also que is this shape. Because it's the cubic function, it's a family of this. But the only problem is 3 up. Plus 3 is 3 unit up. Vertical shape. Okay, super. I need to find now the graph of the inversive function. And the inversive function, remember, is y equal cubic root x minus 3. Oh, but this is easy. Because I know que the inversive function interchange x and y. Always. Entonces, for example, that point, que es 0,3, and the original function and the its inverse function is 3,0. Boom. 3,0. This function become, and the inverse function, you interchange x and y. Super easy. And this is 4,1. 4,1. Like that. 4,1. And here is 2, -1. 2 here. -1, I suppose, is down. Like that. Okay, let me use in green color. The function look like that, guys. Oh, makes sense. Because I know that this belongs to the family. Remember the function cubic root, no? The cubic root look like that. have positive part and negative part. But we have here -3. And -3 represent horizontal shift 3 units to the right because it's negative. Yes or no? Everything makes sense or no? Everything is clear or confusing? Everything is clear or confusing? Guys, this is important because, it's important because when you study the new function of this chapter, we are doing the graph using this idea, no? See, you are doing the graph of the blue and the graph of the green is super easy because the only thing I did was change the position X and Y. But be careful now. Look at that. We have, so this graph, blue and green, is symmetric. We respect the line. Aquí it's a coincidence at that point. The line y equal x. Uy. And this line y equal x represent the identity function. Wow, we discovered this property. Identity function. So when you are doing the graph of the any function and its inverse, they are symmetric. But symmetric with respect the line y equal x. Okay. Stop. Let's move on to Desmos because I want to see in Desmos this idea, pero clear, super elegant. Okay. We switching to Desmos. Switching screen, switching to Desmos. Let me ask a question. Do you see Desmos now or no? Yes? Super. Okay. Yes. Okay. Look at that. This is the example 1. The function is a cubic plus 3. This is the identity function, y equal x, and this is the new one. Okay, in Desmos, we can use in cubic root, but I prefer, I don't know why, don't ask me why, raised to the 1/3 is the same. Look, boom. Okay. Let me do it step by step. Look at that. Okay. Erase everything. Boom. Wow, how many points? 6 points, no? 3. And okay. Erase. I suppose I delete everything at the beginning. Well, okay. This is my original function. It's given. Look at that. The polynomial function, no restriction, no problem. And the typical point, remember, was 0,3. Boom. With the label, it's a y and a z. Negative 1,2. Boom. And 3,0, no, coño. 1,4. 1,4, no? 1,4? Oh, no, I forgot 1,4. Well, okay, I include 1,4. So 1,4. Parenthesis, 1,4. 1,4. Boom. In red color. Do you see the 3 points that characterize perfectly the original function? No. The inverse function that I found and verification. Look like that. Boom. Okay. You see the symmetry with respect to the line y equal x. Ooh. I put in dotted line because it's like a, no asymptote, but it's an auxiliary construction que help me to understand the problem, no? And the point are 3,0. Boom. This point is the reflection of this point. The only thing I did was switching, interchange x and y. 4,1. Boom. This and this. Image. 2,1. Boom. Okay. Any question? Super clear? Super elegant. Let me try to do at least one more example, but I do fast because you know very well everything. Okay, I want to come back to the whiteboard. Switch it to the whiteboard. Okay. Whiteboard now. Do you see the whiteboard? Yes or no? Yes or no? Okay, yes. Yes. Okay. Suppose this example. Wow. This is confusing. Example 2. Okay. Suppose f of x equal x squared. Semicolon x greater than or equal to 0. Entonces yo soy bueno, professor. Every student asks me, professor, what the hell is that part? I don't understand what is that. This is a restriction. This is a restriction. This is domain. So I specification domain. So when you see semicolon, it's because the reason is because this part alone, without restriction, which suppose this without that part. Esa parábola, ¿no? Esa regular parábola que you know very well. Entonces this alone, it's obvious que it's not one-to-one because when you apply the horizontal line test, fail. However, if you introduce the restriction like that, semicolon, x greater than or equal to 0, now it's not the entire parabola, it's the half of parabola. Suppose the positive branch of the parabola, I suppose que I change, I put here another restriction, less than or equal to 0, entonces the negative branch of the parabola. Pero no. The positive is more elegant. And when you apply the horizontal line test, pass. Okay, entonces this function under this restriction is a one-to-one. So the step 1 is to be or no one-to-one. The answer is yes, it is one-to-one. How do you know? Because we are doing the graph. You are doing the graph in decimals. Remember, in decimal, I put f of x equal x squared, and decimal, the symbolic way is you put it here like that. Aromatical decimal understand que it's a half of parabola, not the entire parabola. Okay. Perfect. Now, what's the next step? The next step is find the expression for inverse function. Okay, you know what is that? I suppose it's a square root, no? Intuition. Without mathematics. What is the inverse operation for the square? Square root. But okay, I want to prove. Remember, you copy again the original. You replace f of x for y. And you interchange. This is the most important moment. Interchange x and y. Now x equal y squared. And this is the answer in the inverse function, pero en implicit. But I don't need implicit. I need explicit. And explicit is apply solve for y, do something. I suppose that something is apply square root both sides. Square root x is equal y. Because it's square and square root cancel, and this is explicit. Oh, super. Wait. But I have a doubt. That way I put plus or minus, professor, or no? Because you teach me that when you apply square root, you have two solutions, no plus and minus. What do you think about plus and minus? Both solutions or only one? In this specific case, no? Only one. And the reason, Flora, is clear because I introduced a restriction to be one-to-one function. It was the positive only, right? So the negative, no apply the negative. The negative is wrong. The negative is wrong. Only positive. Entonces, you suppose default, when you omit the sign, it's because it's positive. Entonces, what is the conclusion so far? The conclusion is, for that function, is the classical square function. The inverse function is a square. Under the restriction, in this case, okay. In this case, bueno, okay. Quickly. Verify using the composition. Okay, this is equal identity or no in both directions. In both directions, G composition f of x is identity. Okay. And this G no, hello, inverse function. Okay, for example, in this order is the inverse function I'm using blue color. Go inside this. Entonces es like a square root x squared. Make sense? And you know that this is cancelled. It's no surprise. In this order, let's see, you put inside this, look, the x squared inside this. So it's like a square root x squared. Again, it's good. Very, very good. Our expression is good. Work. What about domain? Domain of the fourth guy. Domain of x squared. Of course, under the restriction this. Bueno, es obvio que es this. Es en interval notation, guy. Es bracket 0,3. And this is equal, by definition, domain of, oh, sorry, no domain, range. Range. This is equal the range of is inverse. And who is inverse? Well, and domain of square root, you know, is x greater than or equal to 0. Yes or no? Remember, in this case, yes, we have restriction. What is the restriction? The expression inside must be non-negative. Okay, by the way, is synonymous to say bracket 0,3. There's a coincidence. You don't know always happen this. And this is equal the range of the x squared. So let's see the graphic. Let's see the graphic. The graphic is, I go to Desmo to see the graphic more clear. No graphic by hand anymore. Okay, Desmos. Okay, good. Let me see Desmo, switching to Desmo. Share window. Okay, this is Desmo. Yes or no? Do you see or no? Okay, but this was example 1, no? And example 2, this was example 1. Yeah, sorry. This new point I put inside the folder. No example anyone anymore. Let's go to example 2. Example 2 is the function. Oh, wait. Okay. The blue function. The blue function is a half of the parabola. How you represent in decimal half of the parabola? Y equal x squared and a specification domain. Inside the curly bracket. X greater than or equal to 0. Okay, so you don't specification, this, look, let me show you. Okay, delete that part. Oh, it's the entire parabola. But no entire parabola. Okay. It's half of parabola because it's 1-to-1. This is the identity function, look. And this is the square root, it's the is inverse. So in orange color, is inverse. Typical point, 0,0 is common. 1,1, okay, by the way, is common. And another point, look at specification, 4,2 and 2,4. Why? Because in the blue, it's a square, 2 square 4. Nice. And the orange is a square root 4 is 2. And you see that both points are symmetric. With respect to the line, y equal x can represent the identity. 1,1 is a coincidence. 0,0 is a coincidence.
So I have a quick question.
Please go ahead.
Sorry to interrupt you.
It's okay. It's okay.
When we're dealing with the half of the parabola, on the positive side, the identity function will always be y equals x.
Yeah. Identity function is a function que the y value and the x value is the same. That is the reason.
So on that sheet that you gave us, that gives you the family of like the parabolas and y equals x cubed and all that stuff. That's where this comes from because it's in that same family, correct?
You're right. Possible.
Okay, understand.
Okay, let me try in the rest of the time. I don't know why. In the last part of the lecture, we need to cover the complicated part. Okay, no problem. One more example. Entonces, we're discussing maybe the most complicated part. Okay, let me try to go again to the whiteboard. Switching to the whiteboard. Okay. Okay. Whiteboard now. Erase the whiteboard. Okay, good. Come on, erase. Suppose the function. Example 3, I try to do something because we have not too much time. Example 3. Example 3 is a function f of x equal 1 over x plus 1. Well, it's actually is the rational function, no? Degree is 0 here and degree 1. But this is extra. No necessary this information. Okay. And by the way, well, okay. By the way, nothing. Okay. What do you think? Is it 1-to-1 or no? It's a 1-to-1. Okay, this belongs to the family of the inverse function, no? Y equal 1 over x. Yes or no? This is reciprocal. Reciprocal. Doesn't yes. The answer is yes. Jordan asked me, we have restriction. Of course you have restriction because we have division. Okay, pero okay. No. It's not giving. No. Sometimes it's giving. Okay, Okay. Sorry, guys. Because when you send me something, are you there? Okay. Are you there, right? Okay. No, because I click in the wrong place and my screen is closed. Okay, look at that. Let me start at the beginning. Okay. Jordan asked me, see, we have no semicolon here. No semicolon. When you have semicolon, when I want to enforce in the situation that this function is 1-to-1, but not always you enforce in the situation. Not always is necessary a specification restriction because natural this function is 1-to-1. So I try to explain. Remember, the fantastic tools that we have to determine if it's 1-to-1 or no is the horizontal line test, no? And the horizontal line test is a your identification, number one, what family belong this function? Well, I suppose que es the family of the reciprocal function. And reciprocal function, do you remember, look like that? This is the graph of this. Okay, the basic. However, we have transformation. In this case, the transformation that we have is x plus 1. What kind of transformation you suppose que have that function? Is plus 1 is vertical shift, horizontal shift, in what direction? Okay, I adding 1. So this is something like that, or this is something like that. What do you think? This plus 1 is inside the parenthesis or outside the parenthesis? Compare. You compare this guy and this guy. Okay, this plus 1 is inside the parenthesis like that or outside the parenthesis. Come on. Help me, because the time is over. Is inside the parenthesis. Very well. Therefore, Jordan, this is horizontal shift or vertical shift?
Horizontal.
Horizontal shift. Very well. No vertical, Jordan, no vertical, horizontal. Es horizontal. Because inside, this is typical horizontal shift. Okay? Si you say que es like that, es horizontal shift. And what direction? To the left or to the right?
Yeah, it's because it's the Y value,
Left.
correct?
Exactly.
To the right.
To the right or to the left?
Left.
Left. Very well. Because it's plus.
Why?
Okay, because it's plus. It's completely opposite to the common sense. Right? When it's plus, it's left. When it's minus, you know, right? Okay, so basically, the graph of this is similar to this because it's family, but it's a little bit like that. Because my question is, when you apply the horizontal line test, pass or fail? What do you think? Pass or fail?
Pass.
Pass. Very well. Entonces, 1-to-1, and we start. Okay, entonces, in the few minutes that we have, I want to find the expression for inverse function. Okay, remember the idea, the basic idea for this. Okay, suppose que the answer is no pass, entonces stop the problem because this function, professor, que you give me doesn't work, have no inverse function. Okay, pero pass. Okay, entonces I replace f of x for y. I interchange f for y. Entonces my expression is x is equal 1 over y plus 1. But this is implicit. I don't like implicit. I like explicit. Entonces for explicit, I need to solve for y. Entonces I use my algebra. I apply solve for y, solve for y, solve for y is the key idea. You apply cross multiplication here. So x times y plus 1 equal 1 times 1 que es 1. Apply distributive property. Xy plus x equal 1. Move this x to the right. Xy is equal 1 minus x. And finally divided by x because I want to isolate y. Okay, and this is my inverse. Okay, sometimes it's not obvious. Sometimes it's very, very confusing. Sometimes you see, oh, multiplication, division, square root, square, cubic root, plus, minus, square root. In this case, no. In this case, no. Come on.
The negative x and the positive x don't cancel out there. I'm sorry.
Positive x and negative x cancel out. No. Of course.
Okay.
No. Okay. 1 minus x division x. And we cannot cancel out. Suppose in the number 3 plus 4. Okay, 3 plus 4 is equal 5 plus 4. We can cancel out that 4? No. Why not? Because when it's plus or minus, we cannot. So I leave it like that. The only possibility is to split this common denominator 1 over x minus 1. Split 1 over x, okay, 1 over x, and negative x divided by x is negative 1. Now these and these are equivalent. But okay. The most important is, guys, the time is over. Okay, listen to me. This is the most important thing. No, the two examples. Normally in the face-to-face class, I explain only 2 examples. I suppose that today I have more time, but no, because I need to explain in detail everything. But now, next class, everyone bring scientific calculator because we start working with a new function that we cannot compute it by hand. Only possibility to compute is using the calculator. In the test, I specification using calculator and express the final answer in decimal approximation. Because the majority of the problem give me irrational solution, but you express it in decimal approximation, approximate or truncate. The decimal, 3 decimal place, 4 decimal place, depending on the problem. Okay, guys. super good today. Okay, appreciate so much your attention. Okay, so now we see again Thursday. Don't forget, submit. I check it now. There are some people that do not submit. This is today due at midnight.